Good evening, everyone. Are you all able to hear me?
Yes, ma'am.
Yeah, okay. Let's wait for 2-3 minutes if some people are joining. Yeah, so I think let us start the session. So, good evening all. I am Harsha. I am from IIT Tirupati. So this is the tutorial session for the NPTEL course Introduction to Abstract and Linear Algebra. So today we will solve some problem related to the week 1 content. So it will help you in understanding the concept more, and you have assignment problem every week. So using this concept, you can solve the problem easily. So if you have any doubt in the week 1 or in the questions, you can clear it here. So basically we will just go through the concept that covered in the last week, and then we will solve some of the problems. So I hope all of you have gone through the contents of the week 1, right? Did you watch the videos of the week 1? Okay. So you might have also tried the assignments also, right? Yeah, please respond to questions, and if you have doubt also, you can ask. Actually, question number 5. I cannot solve the assignment question. That is a graded question. So it is a basic requirement for your exam also. So for that question, I will not solve. Some similar problem I can solve. So maybe that will help you in solving the assignment. Okay. I mean, other than this assignment question, if you have some general doubt, we can try to solve. So let me start the session. So first of all, we share my screen. Is my screen visible for everyone? Is the screen visible? Instead of chatting, if you can talk, it will be better because.
Yes, visible, ma'am.
Okay, thank you. Okay, so in the first week, what are all the things we are covered? So we covered the set now. So you know what is a set, right? So you know what is a set. We have given the definition of the set and the various operations on the sets. So what are all the various operations on the set? We have studied union, intersection, complementation, and so on. Please turn off the mute your audio.
Silent.
All of you please put the video.
Okay, sir. நம்ம வந்து விட்டுறலாமா? You can get PC info. You have to know more.
So we have studied the set and the operations on the set. And what other than that, we have studied Venn diagram. So what is the Venn diagram? It is a pictorial representation. Okay. This is the pictorial representation. If we have some problem using the Venn diagram, we can easily solve the problem. So from set 2, we have gone to relations. Relations, binary relations. And equivalence relation. What is equivalence relation? Can anyone tell what is equivalence relation? So if a relation has some property, then it is called an equivalence relation. What are all the property required for this equivalence relation?
Hello?
Yeah, yes.
Reflexive. Transitive.
Yeah, equivalence relation means the relation should be reflexive,
transitive, symmetric,
and symmetric. I hope you all know the 3 words and what are all the, like, what is the definition of reflexive, transitive, and symmetric. Otherwise, when we go through the questions, we will get to know. Okay. So let me start with a question. So the first question is, given that x in S implies x in T, okay, where S and T are 2 sets, then which of the following options are true? First option is S is a superset of T. Second option is S is a subset of T. Third, S is a complement of T. S is the complement of T. And none of this. So this is one of the very basic question. So can anyone answer which option is true here?
Ma'am, B option.
Yeah, option B. This is the trivial question. X in S implies X in T. That is, any element in S is a element of T also. This is the definition of the subset. That means S is a subset of T. So option B is the correct answer. Okay. So is this clear? Anyone has doubt in this? Shall we go to the next question? So at any point, if you have doubt, you can clear at that moment itself. Let's go to the next question. Let the A and B are two subsets of universal set. Now consider the following statements. First statement is A intersection A. Sorry. A intersection B not a subset of A. And second statement is A symmetric difference B equal to A union B intersection A intersection B complemented. So, which of the above are true? So can anyone, which of these are true? First one, is this true or false? Is A intersection B a subset of A or not?
It's a subset of A.
It is a subset of A. A intersection B is a subset of A. So, one is false. What is A intersection B? It is given that U is a universal set. Okay. A, B are two subsets of U. A intersection B is the set of all elements which are in A and B. That means the shaded region. Obviously, it is a subset of A. From the figure, we can see, right? So, this first statement is false because A intersection B is a subset of A. Okay. Now, what about the second statement? Is the second statement true or false? Okay. What is the definition of symmetric difference? This is already covered, like the definition of symmetric difference. Anyone knows the definition?
A difference B
It's 6:14 p.m.
Can you repeat?
A difference B union
A difference B union
B difference C.
B difference A. Okay. It has one more alternative definition. Anyone know that? We can write it as A union B minus A intersection B. Please mute if you are not talking or asking questions. See, these two statements are equivalent. A symmetric difference of A and B can be either A difference B union B difference A, or it is same as A union B minus or difference A intersection B. Let us see using the Venn diagram. So this is the universal set. A and B are two sets. Okay. So what is A difference B union B difference A? What is the A difference B here? A difference B means set of all elements in A which are not in B. So if I am covering all these region, these are all set of elements in A which are not in B, because this region, this intersection region is in B. So this is the A minus B. Okay. Now what is B minus A? Here, set of all elements in B which are not in A. Okay. This is A difference B union B difference A. That is the red shaded portion union blue shaded portion is the A difference B union B difference A. Okay. We can see that it is same as A union B minus A intersection B. What is A union B? This two shaded region plus the intersection region. So if we are removing that A intersection B from here, then it is same as A difference B union B difference A. So these two are equivalent. Is this okay for everyone? These two statements are equivalent. Is this clear? Is this clear?
Yes, ma'am.
Yeah. Now, in general, if X and Y are two sets, in general, if X and Y are two sets, what is X minus Y, which is equal to X intersection Y complement, right? So this is my X, this is my Y. So X minus Y means this is the region. Okay. This is same as X intersection Y complement. You can see this X intersection Y complement. What is Y complement? The elements outside the set to Y. That means all the region here. Okay. If I am taking the intersection, that is X intersection Y complement, I will get this region here. Okay, fine. So in general, X minus Y is X intersection Y complement. So what we got is symmetric difference of A and B is A union B minus A intersection B. So let me write once again. A difference B equal to A union B minus A intersection B. So if we are applying 1 on this one, what we will get? A union B intersection A intersection B complement. Clear? So this is the statement we have given. A difference B equal to A union B intersection A intersection B complement. So this statement is a true statement. Okay. Is this proof clear? Any doubt here? Is this clear for everyone? If you have any doubt, you can ask. Okay. Now let me go to this doubt. Okay, there is a question. Can you prove empty set is a subset of every set? Let us see that. Empty set is a subset of every set. What is empty set? Empty set we usually denote by phi. Phi means there exists no element inside the set. Okay. Now, what is the definition of subset? A subset of B means X in A implies X in B. This is true for all X in A. If this condition satisfied, that is, if X in A implies X in B for all X in A, then we say we can say A is a subset of B. Now, coming to this condition, does there exist any element in phi? There does not exist any element in phi. That is, in empty set, there is no element. So, what the definition says, if there exists an element in the set, and if that element belongs to the set B, then A is a subset of B. Here A equal to 5 and there is no element in A. So obviously this condition is clearly satisfied. This is trivially false for A equal to 5. For empty set means if we have an element in the set, then only we need to check whether that belongs to the bigger collection, bigger set. So here in the case A equal to 5 means there exists no element in A. So obviously A is a subset of B for all B. Okay. Is this clear? Whoever has asked the question. Who asked the question? Is this clear for everyone?
Yes, ma'am.
Okay. Now, what is this disjunctive union? Who asked this? What is your doubt? Can you please be more clear? Okay. Now let's go to the next problem then. If you have no doubt, then we will go to the next problem. Now the question is, let the set A equal to set of all X in R such that -1 less than or equal to X less than or equal to 3. Then A intersection Z equal to what? So we have 4 options: 0, 1, 2, 3. Second option is -1, 3. Third option is closed 0, 3. And fourth option is -1, 0, 1, 2, 3. So the writing takes a lag here. Please bear with it. So we have already studied intersection and we know Z. Z means set of all integers, positive integers, negative integers, and 0. So the question is, what is A intersection Z? Can anyone say what is the answer here? Okay, before that, do you know what is this representation -1, 3, close to 0, 3 and all? What is the set -1, 3? Do you know? What is it? Okay, option D. Yeah, answer is option D. Okay. Before that, let me explain what is this -1, 3. -1, 3 means set of all elements in R such that -1 less than or equal to X less than or equal to 3. That is set of all real numbers from -1 to 3, including -1 and 3. So if you are representing it as 0, this is -1, 1, 2, 3. So the set of all elements in the real number from -1 to 3 is the set -1, 3. This is the notation. By this we call closed interval. If we are taking the square bracket, we will call it as closed interval. Okay. In the same way, we have one open interval concept also. If -1, 3, the same I am taking -1, 3 with the usual bracket. Okay. This set is set of all real numbers which varies from -1 to 3, but -1 and 3 are excluded. Okay. So what does this mean? If this is -1 and this is 3, if we are taking this point is excluded and this point is excluded. So this is the open interval. Okay. Now, coming to the question. Question is, A is given as set of all elements in R from -1 to 3. That is, here A equal to closed interval -1, 3. Okay. We need to take A with Z, intersection of A with Z. A intersection Z. Okay. Which is equal to closed -1, 3 intersection set of all -3 -2, -1, 0, 1, 2, 3, etc. Okay, set of all integers I am taking. So if I am taking the intersection, I should take the points which belongs to both of this -1, 3 and the integers. So what are all the points like that? -1 is in both. Okay. 0 is also in both because 0 is between -1 and 3. Okay. Next point to 1, next 2, next 3. Okay. It is clear that all the point listed here belongs to both of this set. So any other element belongs to this set? No. If I am taking 4 from this set, 4 from this set, if I am taking, clearly I know 4 does not belongs to -1, 3. Okay. So we get A intersection set, this one. Okay. Option D is the correct answer. -1, 0, 1, 2, 3. Okay. Any doubt in this question?
Teacher, how will we get to know about what when we have to take closed interval numbers or open interval numbers? Like many a times, my teacher told that we should not take closed interval numbers. So I'm asking you.
See, close. Can you repeat your question?
When we have to use that closed interval numbers.
You have to use means it actually depends on the question.
Yes, that's what I'm asking. I didn't understood that.
See, if it is given in the square bracket, some -1, 1. Okay. This means closed interval. If I am given a square bracket with A, B points, A in the left end and B in the right end, this means closed interval. That means both A and B belongs to this AB, means this set. Okay.
Okay, teacher, understood. Thank you.
Yeah. In the same way, open interval means I will take this bracket, not square bracket. Okay. In that sense, A and B does not belongs to that point. All the point between A and B belongs to open interval, but end points A and B does not belongs to. Okay.
Yes, teacher.
Any doubt here? Any other doubt? Okay, let's move to the next question then. Let n be the number of elements in the set A. So what is the number of elements in power set of A?
अब मेरा पासवर्ड तो था फोन नंबर दिखा तो देख
So we have options. A is 2 power n, B 2 power n minus 1, C n factorial, D n power n. So we are given a set A with the cardinality n. Okay, that is number of elements in the set A is n. Now the question is, what is the number of elements in the power set, or what is the cardinality of the power set of A? So first of all, what is the power set of A?
2 power n.
Yeah, answer is 2 power n. Okay, before going to the answer, what is the power set, the definition of the power set of A? Power set of A means set of all subsets of A.
Subset. Okay.
Okay. So the question is, cardinality of power set of A means it is equivalent that how many subsets are there for A. Okay. So let me go to the explanation of that. Suppose A has n elements. A1, A2, etc. A. It is given A has n elements. We are taking it as small a1, a2, etc. A. Okay. Now, to find the number of elements in the power set, we need to find number of subsets of this A. So, subset of this A means A. First of all, the null set, empty set is a subset, right? So, I am listing all the subset of all possible subset of A. So, first of all, number of subsets with 0 element. So, how many subsets are there for A with no element or 0 element? 0 element means no element.
Hello, Mr. Moji sir, who is there? There is lots of background noise. Hello, please mute your mic. Hello,
Yeah, please mute the mic.
because you are disturbing others. Huh? If you are not listening carefully, then you are disturbing others, sir. Please, hello, Then Moji sir, who is Then Moji sir? Hello.
In progress.
Okay, let me mute everyone, please. Please mute if you don't have any doubt or if you are not saying any answer. Okay.
இல்ல பார்ட்டிசிபென்ட் எப்படி பாக்குறது நிறைய பேர் 60 பேருக்கு
अरे अरे कैसे लोग हैं यार हेलो
Okay, coming to the question. So, number of elements, number of subsets with no elements. How many subsets are there with no element?
One.
Yeah, one. Because the empty set, only one. That is, the empty set phi is the only subset which is having no element. Okay. Now, I am listing number of subsets with one element. How many subsets are there?
2.
A is the set A1, A2, etc. A. Okay. So, my question is, how many subsets are there with one element? A subset of A which is having only one element. For example, I am saying A1 is a subset. Set A1 is a subset of A, right? In the same way, set A2 is a subset of A. Clear? And so and so. Set AN is also a subset of A. Clear? So now tell how many subsets are there with one element?
N number of subsets.
Yeah, N number of. Okay. Now, next is number of subsets with two elements. Can anyone answer this? How many number of subsets are with two elements?
4.
Okay, let us just see possibilities. A is set A1, etc. AN. I can take A1, A2. It is two element. Okay, two element subset of A. Other than that, I can take A1, A3. And so on. So I can take A1, AN. In the same way, I can take A2, A3. A2, A1, I don't need to take because A2, A1 is same as A1, A2, right? Just the order changes, but the number of elements means same elements are in both this set. That means I don't need to take A2, A1. So I need to start with the A2, A3, A2, A4, etc. A2, AN. In the same way, I can repeat the process. So there are so many two elements, not four. Okay, so many two element subsets are there. Now, how we are actually taking it? We are taking two elements, that is two distinct elements from A. Okay, what is this actually? This is the combination. We are taking two elements from N elements. That is called the NC2. Okay, this we have already studied in the +2 class. Taking how we can take two elements from N elements, that is NC2. Okay, now in the same way, so this is the number of possible two element subset of A. Okay, is this clear for everyone? Any doubt in this one? Is this clear?
Yes, ma'am.
Okay. Now, in the same way, how I can take three element subset?
NC3.
Yeah, number of three element subset in A is NC3. That is, I am choosing three distinct elements from the given N elements. Okay. So, in the same way, number of N element subset. How many will be there? We have taken two element means NC2. Three element means
NCN, madam.
NCN. NCN is?
2N.
No, NCN is 1.
Okay.
Okay, what is that one? That is, what is that one set? That is A itself. Okay, A has N elements, right? So only possible N element subset of A is A itself. Okay. So we have listed all possible subset of A. So 0 means we got 1. That means 0 element subset means the empty set we got 1. That is 1 is, we know, NC0. NC0. Okay. 1 element subset means we got N. That is NC1. NC1. This is 0. This is the 1 element subset. Choosing 2 element subset means NC2, etc. until NCN. Okay. So, by a known formula, we know that this is 1 plus 1 power N. So, okay, if you have doubt here, I'm just giving it as an exercise. Just see what is A plus B power N, expansion of A plus B power N, and substitute A and B as 1, then you will get this expression. Okay. So this expression is same as 1 plus 1 power n, which is equal to 2 power n. So this 2 power n is the number of subsets of A. Clear? Is this clear? This you do as an exercise. A plus B power n equal to A plus B power n. We can write just in terms of NC0, NC1, etc. and some A powers of A and B. So just try this one and you can see this result. Clear? Any doubt here?
No, madam. Yes, thank you.
Okay. Now, now let us go to the next question. A equal to 0. A equal to set 0, 1, 2. B equal to set x, y, z. Then question is to find A cross B, the Cartesian product of A and B. So, okay. The options are given as 0x, 1y, 2z. Second option is x0, y1, z2. Third option is union of the above two set. x0, 1y, 2z and the last option is none of the above. So, which is the correct answer here?
None of the above.
Yeah, none of the above.
None of the above.
Yeah, this is the very simple question. We know that what is A cross B? A cross B should be set of all x, y such that x in A and y in B. Okay. Here in the first set, actually we are taking only 3 elements of A cross B. Other than this 0x, 1y and 2z, we have 1x and 2x. Okay. Okay. So many elements are there. So all these elements belongs to A cross B. Okay. So this is just A is just a subset of A cross B. Now, what about B? Does B a subset of A cross B? It is not A cross B. Is this a subset of A cross B? Any answer? Is B a subset of A cross B?
No.
No.
No, ma'am.
Yeah, correct. It is not even a subset of A cross B. It is a subset of B cross A. Because in B, we can see that the first element of x0, x comes from the set B, right? So it is subset of B cross A. Okay. Now C is also not correct answer. So what is the A cross B? Do you want me to write what is A cross B? So A cross B will be, so A is 0, 1, 2 and B is x, y, z. So it should list all elements like that. 0x, 0y,
0y, 0z.
yeah.
1x, 1y, 1z. 2x, 2y, and 2z.
2x, 2y, 2z. So we should take all possible pairs from A to B. Okay. What is the cardinality of A cross B?
Cardinality of A into cardinality of B.
Yeah, cardinality of A into cardinality of B. Here it is 9, which is equal to 3 into 3. Cardinality of A into cardinality of B. Okay. And is A cross B equal to B cross A? In general?
No, ma'am.
No, we already seen in the above. So, in A cross B, first element will be in every tuple, first element will be an element from A and second will be from element from B. But in B cross A, all the reverse order we will take. Okay. Is there any doubt in this question?
No, ma'am.
Okay. Good. Now let's move to the next question. So anyone is having doubt, please ask. Please don't keep the doubt with you.
The empty set is a subset of every set. Please explain that.
Yeah, that actually I have explained already. Okay, let me explain once again. Empty set is a subset of every set. Now, what is the definition of a subset? A is a subset of B. When we will say A is a subset of B, if X in A implies X in B. That means if we are taking an element of A, if that element belongs to B for all elements, that is, if I am taking any element of A, it should belongs to B. Then we will say A subset of B. Okay. Now our case is B is any set. Okay. And A we are taking as the empty set. We want to prove that A is a subset of B. Okay. By definition, what we need to prove that any element in A should be in B. Okay. If there exists an element in A, it should belongs to B. Now, in this case, A equal to 5. Does there exist a element in A? Does there exist? 5 is the empty set. There is no element.
No element.
Yeah. If there is an element, then only we need to check whether it belongs to B or not. Here, there is nothing to check. Okay. So, trivially, it is a subset. Okay. This condition is clearly, trivially holds for the empty set.
But there is no element in A, ma'am. How to check this?
Yeah. If the thing is here, what the definition says is for every X in A, X
Okay.
should belongs to A. If there is no X in A, we don't need to check, right?
Okay, ma'am. Okay, ma'am. Thank you.
Yeah. Okay. Now next question is, let A and B two sets. If A union B equal to cardinality of A union B equal to 55, cardinality of A equal to 21, cardinality of B equal to 40, then the question is cardinality of A intersection B. So options are 5, 6, 7, and 8. Okay. So there is a formula to find the cardinality of A intersection B. Yeah.
6, ma'am.
Is this 6?
Option D, 8.
Yeah, option D, 8 actually. Okay. What is the formula connecting A union, cardinality of A union B, B and A intersection B? Cardinality of A union B equal to?
Cardinality of A plus
Coordinate of A plus coordinate of B minus coordinate of A intersection B.
Yeah,
Yeah.
cardinality of A plus cardinality of B minus cardinality of A intersection B. So how actually it comes is, if I am considering the universal set A, B are two subsets. Okay, I need to find cardinality of A union B. This is our A union B. So first I am taking cardinality of A. So it will cover all this portion. Okay. Next time I am taking cardinality of B. It will cover all this portion. So what it happens is, this A intersection B portion is covered 2 times. Okay, A intersection B counted 2 times. That is why we are subtracting this A intersection B from here. Here, cardinality of A plus cardinality of B contains A intersection B 2 times, but we need only 1 time, right? So we are subtracting 1 times. So we are just substituting this formula here. Here, A union B is 55, cardinality of A is 21 plus 40 minus cardinality of A intersection B. This implies cardinality of A intersection B equal to 61 minus 50. Okay, so answer is 6, right? Okay, is this correct? Okay, is this clear for everyone?
Yes.
Okay, so answer is 6. Okay, not 8, I think I said 8. Okay, any doubt here?
No,
No,
ma'am.
ma'am.
Okay.
No, ma'am.
Now we have a set, some sets. We need to check which of the following is a null set. So first one is set of all M in Q. What is Q?
Set of all rational
Set of all
numbers.
rational numbers.
Set of all rational numbers. Second option is set of all M in R such that M square equal to 5. And the third option is set of all M in R such that M square plus 8 equal to 0. Set of all M in R plus. R plus means set of all positive real numbers such that M square equal to 25. Okay. So our question is to find the null set among all these sets. So we will go by option. So what is the first option? Set of all elements in rational such that M square equal to 9. Can you tell what is this set A? What are all the elements in A?
3 and minus 3.
Yeah, 3 and a minus 3. Because 3 square is 9 and the minus 3 square is also 9. And both 3 and minus 3 belongs to Q. So all conditions of A satisfied. So this is the required set. Okay. Now it is not an empty set. So this is not our answer. Now coming to the second option. Set of all M in R such that M square equal to 5. Now what are all the elements in B?
Plus or minus root 5.
Yes, either root 5 or minus root 5. So this is also not empty. Okay, 2 elements are there in B. And also one more thing to note is, here we are taking set of all M in R such that M square equal to 5. M square equal to 5. Okay, that is why we are able to take root 5 and minus root 5 belongs to this option. If it is given that set of all M in Q such that M square equal to 5, Then what will be this set?
5.
Yes,
It will be an empty set, ma'am.
it will be an empty set. Because even though for plus root 5 and minus root 5, we know m square equal to 5. But this plus or minus root 5 does not belongs to Q. But it belongs to R. Real number. It is an irrational number. So it does not belongs to Q, but it belongs to the R. That is why we are able to take root 5 and minus root 5 in the set B. But if it is given that m in Q such that m square equal to 5, then it will be an empty set. So in the given option, it is not an empty set. Clear? Now, coming to the third option. Okay. Coming to the third option, C. Set of all m in R such that m square plus 8 equal to 0. Any element in C?
No, ma'am.
No. Because suppose m square plus 8 equal to 0, then m square should be equal to minus 8. Okay. This is not possible, right? If we are taking any element and its square, means we are dealing with the real number only, not complex number. So, if m square equal to minus 8 means there does not exist such m in real number, because the square of any real number is a positive real number. Okay. So, this C is an empty set. Is this clear?
Yes, teacher.
Yeah. Now let's go to the fourth option. Set of all m in R plus such that m square equal to 25. So, is there any element in this set?
Yes, ma'am. 5 will be there, ma'am.
5.
5 is an element, but minus 5 is not an element because minus 5 is a negative real number. Okay. So, this is also not
Means
an...
R plus means positive real number, right?
Yeah, R plus means positive real numbers.
And Q?
Q, rational numbers.
Okay, thank you.
Yeah. If we are getting Q plus, then it is positive rational number. Okay. So we got C is an empty set, all others are non-empty. So our answer is, question was to find the empty set. So answer is C. Okay. Any doubt in this question? Anyone has doubt? Okay. Can we solve this problem using Venn diagram? Which problem? Can you be specific? Which problem? I didn't see this message at that time. Yeah, who has tapped this message?
Madam, second question, one doubt, ma'am. Both option 1 and 2 are, it is, I think it is false, because A del B, the difference A del B is A union B intersection B complement.
Yeah. Okay, you want to do that once again?
Yeah.
Yeah. In the second option, right?
Yes, ma'am.
A del B equal to A union B intersection A intersection B complement. This was
Yes.
the right?
Yes.
Okay. So by definition of A del B, it is defined as A minus B union B minus A. Okay.
Okay, ma'am.
It has one alternate definition that I can prove. A union B minus A intersection B.
Okay.
Okay. First
Okay.
okay, do you want to prove this equivalence? These two are equivalent? I have already proved it.
Yes, yes, ma'am.
Do you want to repeat?
Madam, it is clear, madam. Both definition are clear, madam.
Oh, both definition are clear. Okay, from this you can write it as,
Ma'am?
yes,
Yeah. Madam, please explain, madam.
okay, the equivalence of these two. Okay. So this is our universal set U. And this one is A, this one is B. Okay.
Okay.
What is A minus B? The set of all elements in A which are not in B.
B.
That means this portion.
Yes.
And B minus A means this portion.
Yes, ma'am.
Okay.
Okay.
Now union means these two portions together.
Yes.
This is same as A union B minus A intersection B, right? This is the A intersection B portion.
A intersection B portion.
So if I am taking A union B means the whole this portion will come.
Okay.
So if I am taking A union B minus A intersection B, it is clearly seen that both are same.
Yeah. Okay. A union B.
So from A union B, that intersection region I am removing. So that is exactly same as the red shaded portion, right?
Yes, ma'am.
First definition. That red shaded portion is our first definition.
Okay.
Okay. From A union B, if I am removing the blue portion, which is same as the first definition.
Yes, ma'am.
So both are equivalent. Okay.
A intersection B complement. Okay, ma'am.
Okay.
Okay, ma'am.
From second to third also.
Okay, madam. Clear, ma'am. Clear.
Okay.
Thank you.
Yeah. Now next question is, A and B are two subsets of universal set S. Then what is A union A minus B complement? This is the question. So options are A, second one is set B, third one is S, and fourth one is A minus B. Okay. So if we are having this kind of question, the best way to approach is using the Venn diagram. So we will draw the Venn diagram. Okay, this is my A, this is my B. The question is A union A intersection M. Any doubt?
Option C, ma'am. I think option C is the answer.
Option C is correct. So, okay, we will go step by step. So, what we need to find is A union A minus B complemented. So, let us see stepwise. Otherwise, it may not be able to follow for someone. So, what is A minus B? Set of all elements in A which are not in B. Okay, this region is A minus B. Now, if I am taking the A minus B complement, 1 minute. This is A, this is B, and this is A minus B. Okay. Now, what I want is A minus B complemented. A minus B whole complemented. Okay. So, the set of all elements which are not in A minus B. Now, we know what is A minus B from the first figure. So, what is A minus B complement? The elements which are not in A minus B. So, this is the A minus B complement. Clear? Now, our question is A minus B complement union A or A union A minus B complemented. So, what is A here? This is our A. Okay. So, this is our A union A minus B complemented. So, what is this? It is yes. It covers full universal set yes, right? Clear? So, answer is
Clear, ma'am.
option C.
Yes, ma'am.
Okay. Anyone has doubt? Okay, if no doubt, let's go to the next problem. So if you are getting this kind of problem, just draw the Venn diagram and you will get the answer easily. Okay. Now, next question is, let the n be a positive integer. I'm defining a relation like this. It is defined on n by A related to B if and only if this is the relation A minus B is divisible by n. Then the question is to find whether this relation is what kind of relation. Okay. So the options are reflexive only. Second option is symmetric only. Third option is transitive only. And fourth option is an equivalence relation. Okay. What does this relation means? Is this clear for everyone?
Madam, answer is the equivalence relation, ma'am.
Okay, answer is equivalence relation. So let's go to the solution. Okay. So first let me explain what it actually means, what the definition means. So the thing is A is related to B if A minus B is divisible by n. That means if n divides A minus B, or equivalently we can say that A minus B equal to some k times n. Okay. So this is the thing. If this condition is satisfied, then we will say A is related to B. First, we will check the reflexive condition. What is reflexive? A should be related to A. Is this true? Whether A is related to A?
No.
Yes, because if A is related to A, then A minus A should be a multiple of n. That is, whatever the n should divide A minus A. It is true. A minus A is 0. This is 0 times n, right? So, it is a reflexive relation. Okay. Is this clear?
Yes, ma'am.
Okay. Now, let us go to the symmetry condition. What is the condition symmetric? If A is related to B, then B B should be related to A, right? Okay. We are taking A is related to B. That implies A minus B equal to sum Kn. Clear? So what we can write as B minus A? B minus K A equal to minus K times N, right? Okay.
Yes, I didn't understood this.
Sorry, can you repeat?
Yes, I have not understood this.
Okay, you didn't understand. So we need to check the condition symmetric. Okay, did you understand the relation? What is the definition of the relation?
Yes, ma'am.
Okay, so the symmetric you want to prove, right?
Yeah.
So symmetric means if A is related to B, then B should related to A. Here, A is related to B. By definition, what is the definition of the relation given here? A is related to B if and only if A minus B is divisible by N. Okay. Divisible by N means it is a multiple of N. That means A minus B is some K times N. Okay. To prove the symmetricity, we want to prove that B is related to A. Okay. That is, we want to prove that B minus A equal to some multiple of N. Okay. We already know that A minus B equal to K. Okay. I am taking the negative of this one. That is, A minus B equal to Kn implies minus A minus B equal to minus Kn. Correct? That implies B minus A equal to Kn. Okay. Sorry, minus Kn. Okay.
Yes, teacher, I understood.
Yeah, B minus A equal to minus Kn. So what does this means? We got B minus A equal to some multiple of N. That means B is related to A by this relation. Okay.
Yes.
So this is symmetric also. Anyone has doubt here? Okay. Now we will go to the transitivity. In transitivity, we have two conditions. A is related to B and B is related to C. Then we need to prove that A is related to C. Okay. So A is related to B implies A minus B equal to some K1 times N by definition. Is this clear?
Yes, teacher.
Now, in the same way, what we can write here in the second one, B is related to C means?
B minus C is
B
equal
minus C equals to K2N.
Yeah, some K2 times N. What we want is A minus C should be equal to, if it is transitive, it should be equal to some K3 times N, right?
Yes, teacher.
Yeah, how we
Yes.
can write it in this form? Using these two conditions, we only have these two conditions. We need to prove that A minus C equal to some multiple of N. How we can use these two conditions here?
We can add and subtract B, ma'am.
Yeah. A minus C equal to A minus B plus B minus C, right? So what we will get, A minus B is K1N plus B minus C is K2N. This we can write it as K1 plus K2N. We can take it as K3. Okay. So we got A minus C equal to K3N. So A is related to C by this relation. Okay. We are getting the transitivity also. So we are getting all the condition, reflexive, symmetric and transitive. So it is an equivalence relation.
Yes, ma'am.
Okay. Any doubt in this question?
No, ma'am.
Okay. Now let's move to the next question. Okay, it's a simple question. Which of the following are true? First option is Z is subset of N. Second is Q subset of N. Third is Q complement subset of R. And fourth is Q subset of Q complement. Okay, which one is true?
Option C, ma'am.
Yeah, option C is the answer. So let's go to each option. So Z is not a subset of N. What is the reason?
Ma'am, Z is the collection of integers and N denotes natural numbers.
Natural
So
number.
we can say that N is a subset of Z, ma'am.
Yeah,
Not
N is a
Z
subset of Z. Because Z contains more elements than N. Means the element which is not in N is also contained in Z. For example, -1 belongs to Z, but -1
also in Z.
Sorry, can you repeat? Okay. So this Z is not a subset of N. Okay. In the same way, in B, Q is not a subset of N. Because N contains only 1, 2, 3, etc. But Q means it contains rational numbers like 2 by 5, 3 by 5, etc. For example, 2 by 5 belongs to Q, but 2 by 5 does not belongs to N. So we can say Q is not a subset of N. Now, Q complement means set of all irrational numbers. Obviously, real number contains all the rational and irrational. So C is true. Okay. And D is clearly false because for whatever the set, X cannot be contained in the complement of it. Okay. So it is false. Is this clear? All the options? Any doubt here?
No, ma'am.
Okay. Very few are responding. If others have any doubt, you can ask. So now let's go to the next question. If S and T are two finite set, what is mean by finite set?
Limited.
Finite
The
number of
limits are limited.
Yeah, a finite number of elements. That means we can say like 5 number of elements, some 10 number of elements. We can say like that.
The elements are limited.
Yeah, elements are limited. S and T are two finite set containing M and N elements respectively. That is, S contains M elements and T contains N elements. Then number of distinct relations from S to T. Options are 2 power M, 2 power N, C M plus N, D 2 power Mn. So what is the answer here? Question is number of relations from S to T.
Option D.
Yeah, option D. So let's try to solve this problem. So what is a relation? We are given S and T two sets and a relation from S to T. What is a relation from S to T? By definition, a relation means a relation R is a subset of S cross T. Okay. That means relation will be some collection of elements x, y such that x in S, y in T. And this x is related to y in some sense. That we don't know, that some definition will be given. If x is related to y in some sense, we will collect all such pairs x, y. Then that is the relation. Basically, R is a subset of the Cartesian product S cross T. Okay. So, if we are taking all the subsets, we can see as relations. Each subset is a relation. Okay. So, number of relation is same as number of elements. No, subsets of S cross T. Okay. Any relation is a subset of S cross T. So we need to count the number of relations. It is same as the number of subsets of S cross T. Is this condition clear? Yes. Okay. So, number of subset of S cross T. What is the number of subset of S cross T? 2 power cardinality of S cross T. Correct? We already proved that if A is a subset, number of subsets of A is 2 power cardinality of A. Okay. Now, what is number of elements in S cross T? Two power number of elements in S into number of elements in T. Number of elements in S is given as M and the number of elements in T is given as N. That is 2 power Mn. Is this clear? This is very simple. Is this clear? Do you want to explain again?
No, ma'am.
Yes, ma'am.
Okay. So the option D is the correct answer. Okay. Now let's go to the next question. A set S is given as set of all Mn in Z cross Z such that M minus 1 into N minus 3 equal to 19.
Amenta, please mute your mic. How careless you are.
Yeah, please everyone mute if you are not talking. Okay. So S is given as set of all Mn in Z cross S, M minus 1 into N minus 3 equal to 19. So this is basically a relation. This is a subset of Z cross Z and it is a relation in Z. Correct? How this relation is defined? The tuple Mn should satisfy the condition M minus 1 into N minus 3 equal to 19. Clear? So the question is, what is the cardinality of S? Okay. So cardinality of S means we should find the number of elements in S. So what are all the possible pairs Mn such that M minus 1 into N minus 3 equal to 90. Okay. So basically we need to evaluate the condition M minus 1 into N minus 3 equal to 90. Okay. So if M minus 1 into N minus 3 equal to 19, what are all the possible conditions for M minus 1 and N minus 3? How can we take the product such that it to M minus 1 and N minus 3 such that its product is 19?
Either 1 or 19.
Yeah, 1 or 19, because 19 is a prime. 19 can be written as 19 into 1. That is, or 1 into 19. Or 2 more possibilities are there. Because it is in Z, not natural numbers. Okay, we have two possibility, m minus 1 equal to 1 and n minus 3 equal to 19. And second case is m minus 1 equal to 19 and n minus 3 equal to 1. And what will be the third and fourth case? We have negative integers. Can anyone tell what is the possibility? I can take it as 19 as minus 1 into minus 19, right? M minus 1 equal to minus 1.
Yes,
N
ma'am.
equal to minus 19. This is also a possibility because minus 1 into minus 19 also equal to 19. Also, this minus 1 and minus 19 belongs to the Z. Okay. In the same way, fourth possibility is m minus 1 equal to minus 19, n minus 3 equal to, sorry, minus 1. Okay. Any other possibility? Any other integer possibility? No. Okay. So in each of the case, we can evaluate. In the first case, what will be m? M equal to 2, n equal to 22, right?
Yes, ma'am.
Yeah. In the second case, m equal to 20 and n equal to 4. And in the third case, m equal to 0 and n equal to minus 16. M equal to minus 18 and n equal to 2. Okay. Okay, just check the calculation also. So, what are all the elements in S? Mn, set of all Mn, which should satisfy the condition. So, we solved the condition and we got the possible Mn value, right? So, yeah, tell what are all the elements in S?
20, 4,
Yeah, 222, 20, 4,
0, minus 16.
and minus
First,
8.
we have to write minus 16 and then 0, right? Because it is negative. Or we have to write in the order of m,
No,
comma n.
we should write in the order of Mn.
Okay.
Yeah. We should write M first, then N. That is the order. It is given in the relation. So, we should write like that only.
Okay, thanks.
So, minus 18, 20. So, this is the elements in S. So, what is the cardinality of S?
4.
4.
Okay. Is this clear?
Yes, ma'am.
Okay. Now, let's move to the next question. Okay, it is a kind of repeating question as earlier one. Which of the following is not a null set? Null set means empty set. So, the options are set of all M in Q such that M square equal to 5. Set of all M in R such that M square equal to 9 and 2M equal to 4. C equal to set of all M in R such that M plus 8 equal to 8. D is set of all M in N such that M square equal to 2. Let's just wait for it to finish. Okay. So question is to find the set which is not a null set. Can anyone quickly say what is the answer?
A.
Question is to find not a null set.
C.
Yeah, C. Does A contains any element? The condition is set of all elements in Q such that m square equal to 5. Does there exist an element in Q such that m square equal to 5? M square equal to 5 means m equal to plus or minus root 5, which does not belongs to Q. Okay. So A is a empty set. Clear? Is the first option clear for everyone?
Yes, teacher.
Okay. Now, in the second option, is there any element in the second set?
No, teacher.
No, because suppose we have two conditions in the second set. That means if an element in R belongs to that set, then we need to satisfy both the condition. That means m square equal to 9. What is m square equal to 9 implies m equal to
3.
plus or minus 3. And 2m equal to 4 implies m equal to 2. Okay. So there is no element which satisfy both the condition. Plus or minus 3 satisfy only m square equal to 9 condition, and m equal to 2 satisfy only 2m equal to 4 condition. So there is no element which satisfy both the condition. So the set B is also empty. Clear?
Yes.
And in C is, we already told it is non-empty. What is the element in C?
0, ma'am.
0, because m plus 8 equal to 8 means only 0 is the possibility. So 0 belongs to set of all m in R such that m plus 8 equal to 8. So it is a non-empty set. Now, what about option m square equal to 2? Option D, m square equal to 2 means m equal to
0.
plus or minus root 2. Which does not belongs to the natural number. The set is given as set of all natural number such that m square equal to 2. So D also empty. Okay. Any doubt here?
No.
Yes, ma'am.
Yeah, what's the doubt?
Madam,
No,
kindly
no.
send all questions and answer to our mail ID.
Sorry, can you repeat?
Madam, you can send all questions answers to our mail ID.
Yeah, this PDF actually I will upload. In 2-3 days I will upload, and this live streaming means this video recording also I will upload in the YouTube.
Okay, ma'am. Thank you, ma'am.
Link will be shared with you.
Okay, ma'am.
Okay. Now, okay. Now the next question is, given two sets S, 1, 2, 3, and a relation row on the set S is given as 1, 3. That means only one element, 1, 3 in the relation. 1 is related to 3. Okay. Be a relation on S. So the question is, then the relation row is, question is whether it is reflexive, symmetric, or transitive, or an equivalence relation. So, first of all, is this a reflexive relation?
No.
No. This is not reflexive. What is the reason?
1 is not matched to 1 and 3 is not matched to 3.
Can you repeat? Sorry.
1 is not matched to 1 and 3 is not matched to 3.
Yeah, not that. 2 is also not matched to 2.
Yeah.
If it's reflexive, every element should map to itself. Okay?
Yep.
1, 1, 2, 2, 3, 3. All this element does not belongs to row. So it is not reflexive. Okay. Now, is this symmetric?
No.
No, not symmetric. Reason?
1, 3 is there though, so 3, 1 should be there, but it's not there.
Yeah, 3, 1 is not in row. If AB is there, then BA should be there. Then only it is a symmetric relation. Here 1, 3 is there, 3, 1 is not there. So not symmetric. Now, is this transitive?
Yes.
Yes. Okay, before explaining the third option, let's go to the fourth option. It is not equivalence, right? Because it is not reflexive and not symmetric. So obviously it is not equivalence relation. Now coming to the transitive condition. So what is the condition for transitivity? If A related to B and B related to C, then A should be related to C. Here we have only one trivial element, 1, 3. Okay, 1, 3 in row. But there is nothing to check actually here. Here some 3x is in row. Then only we need to check whether that 1x belongs to row or not. Okay. Here such an element does not exist. So this condition actually trivially holds. The transitivity condition is trivially holds. Okay. Is this clear? Transitivity?
Yes.
Okay. So then if it is clear, let's move to the next question.
Number
Any doubt? Okay, the question is, okay, again, it's a simple question. S and T are two sets with the cardinality of S is 12, cardinality of T equal to 15, and cardinality of S union T equal to 70. Then, what is cardinality of S intersection T? Okay, this
Then
we
have to use the
yeah, we have to use the formula.
yeah. S union T is equals to cardinality of S
Yeah.
plus cardinality of T minus cardinality of S intersection T.
Okay, from this we can take the S intersection T to one
Now
side.
put in the values and we can find out the answer.
It's cardinality of S plus cardinality of T minus cardinality of S union T. Pen, right? Okay.
Yes, ma'am. Answer is 10.
Yeah. It is correct, right?
Yes, ma'am.
Okay. Any doubt here? Anyone? Any doubt?
No, ma'am.
No, ma'am.
Okay.
No, ma'am.
Let's go to the next problem. Now, let the set S is given as set of all M in Z. Z means set of all integers such that mod M strictly less than 5. Modulus means the usual modulus. Okay. Now, what is the cardinality of S? So the options are given as 5, 9, 4, 10. What is the answer?
B. 9.
9. Yeah. So the question is set of all elements in the set of all integers whose modulus value is less than 5. So what are all such elements?
-1,
Yeah.
-2, -3, -4, 0, 1, 2, 3, 4, ma'am.
Yeah. So starting from -4, -5 will not be there because -5 modulus of -5 is 5, which is not strictly less than 5. So it starts with a -4 and a -3, -2, -1, 0, 1, 2, 3, 4. So total 9 elements are there. Okay.
Yes, ma'am.
So option B is the answer. Clear, right? Okay, now let's do a question of the symmetric difference. Given two set of all, S is the set of all elements in R such that -8 less than M less than 4 and T is the set of all M in R such that -2 less than M less than or equal to 11. So the question is to find the symmetric difference of S and T. Okay. So let us see the options. The options are, first option is set of all M in R such that -8 less than M less than or equal to -2. And set of all M in R such that 4 less than or equal to M less than or equal to 1. And third option is set of all M in R -8 less than or equal to M less than or equal to -2. Please mute yourself. And the fourth option is set of all M in R such that -8 less than M less than or equal to -2. Intersection set of all M in R such that 4 less than or equal to M less than or equal to 11. So first let us see what is S, what is T, and then what is symmetric difference of S and T. Then we will come to the options. So S is given as set of all elements in R which varies from -8 to 4. Okay, this -8 and 4 are not included. So suppose
The answer is B, right?
okay, we will solve and then we will check. Okay, now I'm not sure. I think answer is C. Okay, we will see. Okay. So suppose it is -8. This is 0. This is 4. This is -2 and 11. Okay. So the first is set of all M in R such that -8 to 4. That means from here to here. This is our S. This -8 and 4 are excluded. Okay. And our T is set of all M in R from -2 to 11. Here see -2 is not included and 11 is included. So this is our set T. -2 is not included, but this 11 is included. This is our T. Okay. Now, symmetric difference of S and T means S minus T, S difference T, union T difference S. Okay. What is S difference T here? Here, S is from -8 to 4. So, we need to remove all elements of T which belongs to S. So, S difference T means set of all elements in S which are not in T. Okay, what is this? It will contain from -8 to, we need to remove until this -2, means from the right side to this -2, we need to remove. Does the -2 includes this in this set?
Yes.
Yes, because -2 is not in T. So until -2, from -8 to until -2, it should be there in S minus T. -8 to closed interval 2. Okay. Now, what is T minus S? Set of all element in T which are not in S. So what is the T minus S? Can anyone say?
Four included, 11 included.
4 to
11.
11. 4 is also included because 4 does not belong to S. From 4 to 11, it is. Okay. So this is this we can, if we are writing as set of all M in R such that -8 less than M less than or equal to 2 union set of all M in R such that 4 less than or equal to M less than or equal to 11. Okay. Now let's go to the options. Option D is correct, right?
Yes.
Sorry. Okay, option D is the correct answer, right?
Yes, ma'am.
Yes.
Yeah, D is correct. So, is this clear for everyone? Any doubt in the symmetric difference? Any doubt in the solution?
Symmetric difference now union and option D intersection difference.
Okay, sorry. Option D is intersection. Yeah, not D. I think there is something wrong with the option C.
There should be union in like D.
Yeah, not D. Sorry. It is option C, but actually in option C, it is option C, but -8 is not included in our answer, right?
Yes, ma'am.
Yeah, so, okay, let me rewrite this. -8 less than M less than or equal to -2 and 4. Okay, now is it okay?
Okay, ma'am.
Everything fine, right? Anyone has doubt?
No.
Okay. Okay, now let's go to the next question. Okay, the question is S and T are two sets. And the data given here is cardinality of S complement intersection T equal to 10. Cardinality of S intersection T complement equal to 12. And the cardinality of S intersection T equal to 8. Question is, what is cardinality of S union T? Okay, can anyone answer this question? How we can approach?
Yes. Just with the help of Venn diagram, we
Yeah.
can solve that S complement intersection to T is equals to 10, like step by step.
Yes. Okay, let's draw Venn diagram. This is our S. This is our T. Okay.
So So we will find that the
30.
cardinality of T is 10. Exact. Actually.
Okay, let us see what are all the given set S complement intersection T. In this one direction, what is S complement intersection T? It will be this region, right?
Yes, ma'am.
And
Is 30.
okay, and T complement intersection S will be, sorry, this is S intersection T complement, first one. And this is T intersection S complement. Okay. This is S intersection T complement. This is T intersection S complement. And this region is, what is this region?
Yes, intersection
Yes,
T.
intersection T.
S intersection T. So the cardinality of all these three sets, it is already given here. S complement intersection T, S intersection T complement, and S intersection T, right? So
Yes, ma'am.
what is the cardinality of S union T?
I think the answer is 30.
30.
Yeah, we just need to answer, add all these values. Cardinality of S union T is equal to cardinality of X complement intersection T plus cardinality of S intersection T complement plus cardinality of S intersection T. Because these three sets covers the S union T. Okay. So the answer is 10 plus 12 plus 8, which is 30.
30.
Clear?
Yeah, ma'am.
So whatever the question like this, it is very easy to do with the Venn diagram. Just approach this way. Okay?
Yes.
Okay then. Now let's move to next question. Rho is the set of all Mn in Z cross C. That is, rho is a relation in Z. The relation is given as M minus N is divisible by 7. So I think we have already done similar problem. So now, is this symmetric? Okay, let's go directly to the options. So options are rho is reflexive, symmetric, transitive, and not an equivalence relation. Let us check whether it is symmetric. Is this symmetric?
No.
Yes, ma'am.
Yes, because the similar kind of problem we have already solved.
Miss, how
Yes.
it is symmetric? I didn't understand.
Okay, I will explain. So M minus N is divisible by 7. That means M minus N is a multiple of 7, right? Divisible by 7 means it is a multiple of 7. Okay. That means M minus N equal to some K into 7.
Yes.
That is the relation given here. So symmetric means for any M in Z, MM should belongs to Z cross Z. That means M minus M should be equal to some K into 7. What is M minus M? It is 0, which can be written as 0 into 7.
So 0
Okay.
into 7 will be 0, right?
Sorry?
0 into 7 will be 0.
Yeah. So I am taking K equal to 0. So 0 into 7 equal to 0. Clear?
Yes, ma'am.
Okay. So symmetry condition is satisfied, right?
Yes, teacher.
Now, oh, sorry. This is reflexive condition. Yeah, sorry.
Yes, miss, that's fine.
This is reflexive, not symmetric. Okay, M is related to M is the condition of reflexivity, not a symmetry. Now let's go to the symmetry condition. Now, what is symmetry condition means? If Mn belongs to rho,
M should be equal to N.
no, then Nm should belongs to rho, right?
Yeah.
What you said is anti-symmetric.
Hmm.
If Mn and Nm belongs to rho, then M equal to N. Okay, now let's see the symmetry condition. Mn belongs to rho means M minus N is a multiple of 7. Okay. That means just as the earlier case, we can write N minus M equal to just taking the negative in both sides, minus K into 7. So again, we got it is a N minus M is also a multiple of 7. So N is related to M, that is Nm belongs to rho. Clear?
Yes.
Okay. Now, transitive condition.
Teacher,
See.
then it is symmetric, right? Because the answer is negative. And negative belongs to Z, right? Z.
What? Can you repeat?
The answer will be negative, right? Minus K into 7. And it belongs to ZZ. So it is symmetric, right?
Yeah, it is symmetric, yes.
Okay.
What is any doubt?
No, ma'am.
Okay, okay. Okay, now let's go to the transitive. Suppose Mn belongs to rho and some Ns belongs to rho. Okay, what we need to prove that? What is the transitive condition?
M belongs to N and N belongs to
Ms should belongs to rho. Okay, this is what we want to prove. Clear?
Yes.
Yeah. Mn belongs to rho. By the definition, what is this? M minus N is divisible by 7. That is M minus N is some K1 into 7. Ns belongs to rho means what we can write? N minus S belongs to, equal to K2 times 7. Okay. Now adding these two, this is same as the earlier problem. Equal to M minus S equal to K1 plus K2 times 7. So we got M minus S is a sum K3 times 7. That implies Ms belongs to the relation rho. Clear for everyone? Any doubt here in any of this condition?
No, ma'am.
Okay.
No, ma'am.
Okay. Okay, one simple problem. Okay, we will solve this also and then we will stop the session. Given S and T are two sets, two distinct sets. So options are given as S cross T not equal to T cross S. S cross T equal to T cross S. S cross T subset of T cross S. Of T cross S. So I should take the S and T are two non-empty distinct sets. So I am taking the condition non-empty and distinct here. So if it is empty, if any of them is empty, or if they are not distinct, you just go through the conditions again and check what are all the true conditions. Because here, what is the answer? Can anyone, this very simple question. What is the answer here?
A.
Yeah, A is answer. But because in general, S cross T and T cross S are different. Because S and T is distinct, it is taken. and a non-empty is also taken. These two conditions really plays a role for option A to be correct. Because in other case, other option can be correct. You just go through the all the cases, because when it is empty and distinct, go through the all other cases and verify whether it is correct or not. So in this case, A is the correct answer. So anyone want the explanation why B, C, D are wrong with some examples? Anyone want example for that?
Why C and D wrong?
Why C and D wrong? Okay. Let's take some example. Suppose I am taking S equal to 1, sorry. It's equal to 1, 2. One simplest case I am taking. And T equal to nx. Some element x. Okay. What is S cross T? What is S cross T?
1, x.
1, x.
2, x.
2, x. And what is T cross S?
X, 1.
X, 1. X, 2.
X, 2.
Okay. So now S cross T and T cross S are different, right? S cross T and T cross S not equal. And is S cross T subset of T cross S or T cross S subset of S cross T? Any of this condition is satisfied?
No, ma'am.
No. Just see the example. We can say they're completely distinct element. Is like their intersection is also non-empty. Sorry, empty. Okay. Clearly, B, C, D are wrong. Just with this example, we can verify these are wrong. Okay. Is this clear? Whoever asked the question?
Okay, ma'am.
Okay. So I think let's stop the session today. If you have any doubt, you can ask. Otherwise, you can leave. We will meet in the next Sunday with the week 2 questions. Just go through the lecture before coming the live session. So it will be easy to understand. And if you have any doubt, you can ask in the live session. Okay. Any doubt for anyone?
Ma'am, no doubts for me, ma'am. Thank you, ma'am. Thank you so much.
Okay, thank you.
It was a wonderful session, ma'am. Thank you so much.
Thank you so much. So yeah, recording I will upload in the YouTube in 1 or 2 days, and you will get the link from the NPTEL team. And this notes also I will upload in the drive. That link also you will get. So that will be shared with you from the NPTEL team. Okay. To be good in abstract algebra, actually, just understand the concept and through the example. If you are understanding the concept through the example, then it will be easy to remember. So whatever you are doing, just solve the exercise. Solve the exercise related to this. So if you are reading one paper, basically for abstract algebra, I will recommend Fraley's test. So if you are reading, so many exercises will be in any text, so many exercises will be there. So just go through the exercises. So you will be thorough in the concept. So that is the only thing to be good in. Like exercise is the main point, I think.
Hello?
Yeah, yes.
Can you hear me?
Can you speak louder?
Can you hear me?
Yes, yes, tell.
In that you said like in the proof of empty set is all empty set is subset of all set. That proof like in definition A subset of B means X belongs to A, then X belongs to B, then A is a subset of B. It's okay. But in empty set there is no element. Definition says if there's an element, we have to check like this.
Yeah, definition says if there is an element in A, then it should be in B. In empty set, there is no element.
So that how we can say there is no element.
There is no element, so it is trivially false actually. If there is an element, then only we need to check the condition. If there is no element, there is nothing to check. It is trivially false actually. Or you can take it as a convention also. Means empty set is a subset of false set. The thing is, only need to check the subset condition if there is an element. If there is no element, you don't even need to check. You can say it is a subset. That's all.
Like in transitive also, if there is two relations, we have to check. Like X related to Y, Y related to X, then only we have to check.
Yeah. If X related to Y, and if there is another element Y related to Z, then only we need to check whether X related to Z or not. If just one element XY is given, it is trivially transitive. These are all trivial cases actually.
Okay.
Okay.
Okay. Thank you.
Yeah. Yeah, thank you for all attending the session. So if you don't have any doubt, I think I can close the session, right?
Thank you, ma'am.
Yeah, thank you all. You can leave the session now.